The late Cretaceous was a world full of life, beauty, and hidden fragility. Forests stretched across vast lands, filled with towering conifers, flowering plants, and thick ferns that painted the earth green. Inland seas cut deep into the continents, creating rich coastlines where countless creatures thrived. On land, the dinosaurs ruled without rival. Enormous herbivores such as Triceratops and Ankylosaurus roamed in herds, their bodies built for both survival and display. Towering predators like Tyrannosaurus rex stalked the plains, its senses sharpened to detect the faintest sign of weakness. In the skies above, pterosaurs soared gracefully, their wings stretched wide as they glided on warm currents of air. The oceans were alive with creatures no less magnificent. Mosasaurs patrolled the deep like serpentine lords, while giant turtles and fish darted between reefs. Ammonites spiraled through the waters, their shells glittering like ornaments of ancient design. Every ecosystem, from forest to sea, pulsed with energy. It was a golden age, but one balanced on a delicate thread. Ecosystems depended on the cycles of plants, the migration of herds, and the climate that sustained them. The world appeared eternal, unshaken, and destined to endure forever. Yet, hidden beyond the skies, forces were already in motion. In the silence of space, massive rocks drifted endlessly, relics of the solar system's violent beginnings. Two of them, bound by fate and cosmic chance, were on a collision course with Earth. Their journey was slow, stretched over millions of years, but their arrival promised devastation unlike anything this planet had ever known. The dinosaurs, magnificent rulers of their age, had no warning of the shadow creeping toward them. To the creatures of the late Cretaceous, tomorrow would always resemble today. But the heavens had written a different ending, and soon the Golden Age would meet its darkest hour. The Cretaceous Earth was a theater of life at its most extravagant, a living mosaic where every creature, plant, and element played its part. To the casual eye, it looked like an age of stability, a timeless kingdom where dinosaurs ruled endlessly. Yet beneath this apparent permanence, the balance of existence was delicate, dependent on countless threads of interaction that could unravel with the smallest disturbance. The forests were at the heart of this world. Towering conifers rose into the skies, their branches home to insects, early birds, and small mammals that scurried through the canopy unseen. Flowering plants had spread widely by this time, adding bursts of color and fragrance to the Cretaceous landscape, attracting pollinators like beetles and primitive bees. These plants were more than decoration, they anchored entire ecosystems. Their growth fed herbivores, which in turn fed predators, forming chains of survival that stretched across continents. Herbivorous dinosaurs were the living engines of these systems. Hadrosaurs, with their duck-billed mouths, gathered in vast herds to graze on vegetation. Their migrations spread seeds, fertilized soils, and shaped the landscapes they roamed. Ceratopsians, like Triceratops, defended their young fiercely, battling predators with horns and frills, ensuring the continuation of their bloodlines. Ankylosaurs, armored with bony plates and tail clubs, embodied resilience, their very existence a testament to the arms race between prey and predator. Predators, in turn, kept the balance sharp. Tyrannosaurus rex, the apex hunter of the Cretaceous, shaped the world through fear alone. Its presence forced herds to move, to stay alert, to never let their numbers swell beyond what the land could support. Smaller predators like dromaeosaurs darted in the shadows, hunting in packs and maintaining pressure on the weak and vulnerable. In the skies, pterosaurs maintained another layer of equilibrium. Some soared over oceans, diving for fish, while others hunted inland, snatching small animals in their beaks. Their dominance of the air was challenged only by the earliest true birds. whose feathers and flight patterns hinted at the evolutionary triumphs yet to come. Beneath the surface of the seas, an entirely different but equally fragile balance unfolded. Shallow inland seas teemed with ammonites, mollusks, and schools of fish. Mosasaurs, enormous marine reptiles, ruled as apex predators of the waters, their jaws powerful enough to crush turtles and fish with ease. Plesiosaurs stretched their long necks to snatch prey, while sharks circled the depths, testing every weakness in the ecosystem. Coral reefs supported countless smaller organisms, creating a network of life that mirrored the balance on land. Climate played the role of unseen architect. The Cretaceous was a warm world with higher sea levels than today. Polar regions lacked ice caps, and warm currents carried life-sustaining waters across oceans. This climate created fertile lands and seas, allowing dinosaurs and other creatures to thrive in numbers unimaginable today. But this warmth also meant fragility. A slight change in global temperature, a disruption of sunlight, or a shift in rainfall could tip ecosystems into collapse. The balance extended even to the smallest of organisms. Plankton, invisible to the giants around them, were the foundation of the seas. Their ability to photosynthesize fueled the marine food chain, feeding small fish that fed larger predators. Fungi and bacteria recycled dead matter back into the soil, ensuring forests remained fertile. Without these unseen actors, the grand stage of dinosaurs would not have stood for long. This fragile order was not guaranteed. History had shown Earth's capacity for catastrophe. The Permian extinction, hundreds of millions of years earlier, had nearly erased complex life. Even within the Cretaceous, volcanic eruptions, shifting continents, and changing sea levels reminded the world of its vulnerability. Yet in this moment, on the eve of disaster, life appeared unshaken. The dinosaurs themselves, magnificent as they were, could not perceive the fragility. Their senses were tuned to immediate threats: the stalking predator, the shifting weather, the protection of offspring. They had no way to recognize the invisible threads that bound their world together. Nor could they foresee that those threads could be severed not by a predator or famine, but by something far beyond their comprehension. This was a world where continuity seemed certain, where every sunrise promised another day of survival, growth, and dominance. But above the blue skies of the Cretaceous, beyond the clouds and the warmth of the sun, two silent wanderers of stone and ice drifted closer. The balance that had taken millions of years to shape was about to meet its most brutal test. The fragile harmony of Earth's ecosystems, built on interdependence and stability, was destined to collapse not from within, but from the cosmos itself. And when it did, the Golden Age would vanish in a storm of fire, darkness, and silence. Space is a graveyard of ancient battles. Planets, moons, and asteroids are relics of the solar system's violent birth, fragments of rock and ice that never found a permanent home. They wander endlessly, tugged by the gravity of giants, nudged by invisible currents, and reshaped by collisions that echo across billions of years. Most pass unnoticed, their journeys silent and uneventful, but every so often one is drawn toward Earth. And in the late Cretaceous, two such travelers were moving closer, destined to end the reign of the dinosaurs. Their origins stretched back nearly to the beginning of the solar system. 4.5 billion years ago, dust and gas swirled around a newborn sun, coalescing into planets and moons. Not all fragments found a stable orbit. Many were left adrift in the asteroid belt between Mars and Jupiter, where the pull of Jupiter's gravity kept them from ever uniting into a planet. Here, collisions were constant, smashing rocks into smaller pieces, sending shards spiraling into new paths. The two asteroids that would one day collide with Earth were born from this chaos.
For millions of years, they drifted in quiet darkness, cold and unchanging. They were unremarkable, just two of countless fragments caught in endless motion. But orbits are never truly still. The slightest gravitational nudge can alter destiny. Jupiter's immense pull, the subtle forces of the sun's radiation, and the impacts of other rocks all conspired to shift their courses. Slowly, invisibly, these two asteroids were nudged out of the belt and into a trajectory that would intersect with Earth. One was massive, nearly 10 kilometers across, large enough to carry the energy of billions of nuclear weapons. Its surface was scarred by eons of smaller impacts, craters within craters marking its violent history. The other was smaller, perhaps a third of that size, but still devastating by any measure. Either one alone could reshape the planet's biosphere. Together, their arrival would amplify destruction beyond imagination. From Earth, their approach was imperceptible. The skies of the Cretaceous were bright and familiar. To the dinosaurs grazing below, nothing had changed. The moon still glowed at night, the sun still warmed the land by day. Even the most keen-eyed pterosaur soaring high would not have noticed the faint points of light moving among the stars. But the signs were there. To a human observer transported back in time, the night sky might have revealed unusual glimmers, tiny specks that shifted position over weeks and months, brighter than the surrounding stars. They would have seemed harmless, insignificant. Yet those faint sparks carried the seeds of extinction. As the asteroids moved closer, gravity became their guide. Earth's pull began to bend their paths, dragging them inward, locking their fate with the planet below. They accelerated, gathering unimaginable speed. By the time they would reach Earth's atmosphere, they would be traveling faster than a bullet, faster than sound, faster than any creature alive could comprehend. Their journey across space was not a deliberate mission, not a weapon aimed with purpose. They were simply wanderers, obeying the laws of physics, caught in an ancient dance of gravity and motion. But for life on Earth, their timing was catastrophic. Ecosystems had flourished for millions of years, unaware that a countdown was already underway. The asteroids carried more than raw energy. Their impacts would release heat enough to ignite forests, pressure waves strong enough to level mountains, tsunamis that would sweep across continents, and dust clouds that would choke the skies. Together, they would create a chain reaction unlike anything Earth had seen since the Permian extinction, when nearly all life had been extinguished. Still, as they closed in, the Earth below remained unchanged. Hadrosaurs continued to graze, Triceratops guarded their young, Tyrannosaurs stalked the shadows, and Ammonites drifted peacefully in the seas. Life went on, oblivious to the disaster racing toward it. The signs in the sky were faint, almost invisible, but they were enough to herald the end of an age, enough to mark the beginning of a catastrophe. The golden age of the dinosaurs had only moments left in the cosmic scale of time, and soon the skies that had nurtured them would become the source of their undoing. Extinction stories are often told in absolutes. One cataclysm, one moment of devastation, one asteroid that changed everything. The Chicxulub impact in what is now Mexico is usually portrayed as the sole executioner of the dinosaurs. It is the most famous crater on Earth, nearly 200 kilometers across. Its buried scar still visible beneath the Yucatan Peninsula. The evidence is overwhelming. Molten rock frozen in time, shocked quartz, and a global layer of iridium-rich dust, a fingerprint of cosmic origin. But the story may not be so simple. Over the past few decades, scientists have uncovered clues that suggest the dinosaurs may not have been struck down by just one asteroid, but by two. This possibility, known as the multiple impact hypothesis, adds a new dimension to one of the most dramatic events in the history of life. The idea first arose when researchers began comparing the geological record from around the world. In addition to the Chicxulub layer, another set of impact signals appeared in deposits far away. In Ukraine, a structure known as the Boltish crater was dated to roughly the same period. Though much smaller than Chicxulub, measuring about 24 kilometers across, it hinted that Earth might have endured more than one strike during the extinction event. At first, skeptics argued that Boltish was formed hundreds of thousands of years later, during the recovery phase after the dinosaurs' extinction. But further analysis complicated this view. Refined dating techniques placed Boltish closer to the Chicxulub event than once thought, possibly within tens of thousands of years or even less. Other sites added weight to the idea. In Canada, the marine Marlborough Formation showed signs of impact spherules, tiny glass beads formed when rock is vaporized and then rains back to Earth. Similar deposits were found in Europe and Asia, their distribution difficult to explain with only one impact. Perhaps Chicxulub alone was responsible, flinging debris around the world. Or perhaps, as some argue, multiple asteroids left overlapping signatures, their combined chaos blending into one global layer. The possibility of a double strike is not far-fetched. In our solar system, asteroids are rarely isolated. Many exist in families, broken pieces of larger bodies shattered by collisions. Some travel as binaries, two rocks locked together by gravity, circling one another as they move through space. If Earth encountered such a pair, both could have entered its atmosphere within hours or even minutes of one another, striking in different places. What would this have meant for life on Earth? The Chicxulub impact alone unleashed destruction on a planetary scale. Shockwaves circled the globe. Fires consumed forests. Tsunamis drowned coastlines, and the sky darkened with soot. A second impact, even smaller, would have magnified the catastrophe. It would have added more dust to the atmosphere, more fires, more waves of destruction. For ecosystems already teetering, the double blow could have been the difference between partial survival and total collapse. The mystery deepens when we look at the extinction patterns themselves. Not all species vanished instantly. Some groups declined before the impact, weakened by climate shifts and volcanic eruptions, such as those in the Deccan Traps of India. Others lingered for thousands of years afterward. The layered destruction of volcanism, climate instability, and possibly multiple asteroids paints a picture not of a single death blow, but of a prolonged and brutal assault. Still, Chicxulub remains the centerpiece. The crater's size, energy, and global effects are undeniable. Any second asteroid would not diminish its role, but it would reveal that fate struck the Earth with an almost cruel redundancy. Two cosmic hammers falling at once. Scientists continue to search for answers. Improved radiometric dating of craters, chemical fingerprinting of impact layers, and computer simulations of asteroid families all bring us closer to the truth. The more we learn, the more the extinction of the dinosaurs appears not as a single moment, but as a series of events woven tightly together. To the dinosaurs themselves, the mystery never mattered. They would have known only the fire, the darkness, and the silence that followed. But for us, the possibility of multiple impacts changes how we understand survival and chance. Had only one asteroid struck, perhaps some dinosaurs might have endured longer. Had both been larger, perhaps life as we know it would never have recovered. The mystery of multiple impacts reminds us of the fragility of existence. Our planet, vibrant and alive, orbits through a cosmos filled with wandering stones. Most pass harmlessly. But as the Cretaceous shows, sometimes fate delivers not one strike, but two. It was a wanderer born from chaos, a remnant of the solar system's violent youth. 10 kilometers across, heavier than mountains, moving with a speed no living creature on Earth could comprehend. For millions of years it drifted in silence, unremarkable among countless rocks scattered through the darkness of space. But by the late Cretaceous, its path had shifted and its destiny was sealed. It was heading toward Earth. To understand the scale of this asteroid, imagine a rock the size of a city, moving faster than a bullet. By the time it neared Earth's atmosphere, it was traveling at more than 70,000 kilometers per hour. The sheer energy of its motion was unimaginable. Scientists estimate its impact released over 100 million megatons of energy, more than every nuclear weapon on Earth combined. It was not just an object, it was a force of nature, a cosmic weapon shaped by chance. Its surface told the story of its long journey. Pitted with craters from smaller collisions, covered with dust and debris, it was scarred by the scars of time. It may have been a carbonaceous chondrite, rich in iridium and other rare metals. This chemical fingerprint, found in the thin global layer of clay deposited after the impact, would one day provide the evidence for its extraterrestrial origin. As it approached Earth, the planet's gravity pulled it in, accelerating its fall. The asteroid pierced the atmosphere in seconds, compressing the air in front of it into a wall of heat and pressure. The skies above the Yucatan Peninsula ignited in a flash brighter than the sun. Dinosaurs grazing nearby would have seen the horizon explode in light. There was no time to run, no time even to react. The asteroid struck the shallow waters of the Gulf of Mexico with a force beyond comprehension. In an instant, the seafloor vaporized. Rock turned to liquid, liquid to gas, creating a fireball that expanded outward with the energy of creation itself. The impact carved a crater nearly 200 kilometers wide and more than 30 kilometers deep, displacing trillions of tons of material. The immediate devastation was apocalyptic. Shock waves raced outward faster than sound, flattening forests and toppling mountains. Tsunamis hundreds of meters tall surged across the seas, racing toward coastlines and drowning everything in their path. Molten rock and vaporized water blasted into the sky, creating clouds of superheated debris that rained down across continents. The fireball ignited the world. Forests burst into flames, and wildfires spread uncontrollably, fueled by debris raining from the skies. The air itself became a weapon. Winds faster than hurricanes roared outward, stripping leaves from trees and hurling animals into the air. Nothing within hundreds of kilometers survived. Yet the impact was not only local. Its consequences were global. Vaporized rock and dust spread into the atmosphere, blocking sunlight. The thin, iridium-rich layer deposited in soils around the world is silent testimony to this moment. Without sunlight, photosynthesis faltered. Plants withered. The base of the food chain began to collapse. The oceans, too, bore scars. Acid rain fell from the sky, poisoning waters and killing plankton. Without plankton, the marine food web began to unravel. Ammonites, which had survived for hundreds of millions of years, disappeared. Mosasaurs and plesiosaurs, rulers of the seas, soon followed. For the dinosaurs, the end came in waves. Some died instantly in the blast. Others starved as plants vanished and herbivores fell. Predators like Tyrannosaurus rex, once kings of the land, found themselves without prey. Even the mighty could not endure the silence that followed. The Chicxulub asteroid was more than a rock. It was a turning point in the story of life. In a single day, it ended the reign of creatures that had dominated the planet for over 150 million years. But in doing so, it cleared the stage for something new. Mammals, once small and insignificant, would rise in the absence of the dinosaurs. From their survival, humanity's story would one day unfold. And yet, the tragedy of Chicxulub may not have been solitary. If Earth faced more than one asteroid, then this was only the first hammer blow. Another rock, smaller but still catastrophic, was already on its way. The giant killer had struck, but the planet's torment was not yet over. While the Chicxulub asteroid is remembered as the Great Destroyer, the world may have faced another, smaller, but still catastrophic visitor from space. This second asteroid has been called the Silent Partner, a force less famous, yet no less important in shaping the apocalypse of the Cretaceous. Scientists debate its timing and its place of impact, but evidence suggests Earth endured more than one strike during the final days of the dinosaurs. The Boltish crater in present-day Ukraine offers one of the strongest clues. Buried beneath sediments and long forgotten, it measures about 24 kilometers across, dwarfed by Chicxulub, but still vast enough to annihilate ecosystems on a continental scale. Dating the Boltish crater has proven challenging. At first, it seemed younger than the Chicxulub impact, occurring perhaps a few 100,000 years after the extinction. But refinements in radiometric analysis suggest it may have been nearly simultaneous, within tens of thousands of years, or possibly even closer. If so, it means Earth endured not just one, but two hammer blows in rapid succession. Consider the consequences. The Chicxulub impact had already unleashed a planetary inferno. Fires raged, seas boiled, skies darkened. The biosphere staggered under the weight of the first catastrophe. Then, while the world was still smothered in soot and struggling for breath, the second asteroid struck. Smaller in size, perhaps 2 to 3 kilometers wide, this rock still carried the energy of millions of nuclear bombs. It slammed into Earth with violent force, carving a crater, vaporizing rock, and sending shock waves through land and sea. Local ecosystems were obliterated in seconds. Forests fell, rivers boiled, and everything within hundreds of kilometers was reduced to ash. But the true devastation was not just local. More dust and vaporized rock entered the atmosphere, joining the choking cloud already unleashed by Chicxulub. More fires ignited, more acid rain poured, more tsunamis swept across the seas. What little chance remained for fragile survivors was crushed under this second blow. The effect of two near-simultaneous impacts was not simply additive, it was multiplicative. Each catastrophe fed the other, amplifying destruction. Fires from Chicxulub had already stripped forests bare, leaving landscapes vulnerable. The second asteroid turned smoldering ruins into deserts. Marine ecosystems, already collapsing from the loss of plankton, now faced new waves of poison and sediment. For the dinosaurs, the double strike was merciless. Some species might have endured the first impact by retreating into pockets of unburned forests or sheltered valleys. But when the second asteroid struck, those refuges vanished. Herds of hadrosaurs that had survived the initial chaos found their food sources gone once more. Predators weakened by hunger faced even greater scarcity. In the oceans, ammonites, once resilient survivors of earlier extinctions, were overwhelmed. Mosasaurs and plesiosaurs, already starving as plankton disappeared, found themselves in seas made more toxic and barren by the second strike. Even resilient species like crocodilians barely endured. Their survival owed to their ability to withstand long periods without food. The second asteroid's legacy may explain why the extinction was so absolute. Previous mass extinctions had left survivors in greater numbers, but the end Cretaceous event was unusually thorough. Almost no large animal on land survived. Entire clades of marine reptiles vanished. Even the skies emptied of pterosaurs, leaving only birds to carry flight into the next era. A single asteroid could explain devastation, but two together made survival nearly impossible. Yet, as devastating as it was, the Silent Partner remains hidden in history. Unlike Chicxulub, its story is buried, its crater less visible, its memory faded. It does not dominate popular imagination, but its role may have been crucial, ensuring that the extinction was not partial but complete. sealing the fate of the dinosaurs and reshaping the trajectory of life. For the creatures of the Cretaceous, there was no knowledge of two asteroids. There was only chaos, fires, darkness, starvation. But for us, piecing together the clues millions of years later, the possibility of a double impact adds a chilling depth to the story. It tells us that fate can strike not once, but twice, and that survival can hinge on the cruel timing of the cosmos. In the end, the Silent Partners story is one of amplification. Chicxulub might have been enough on its own, but the second asteroid, smaller yet devastating, ensured that the reign of the dinosaurs ended not with resistance, but with silence. And so, two wanderers from the void arrived together, hammer and anvil, to crush the Age of Giants. The late Cretaceous morning began like countless mornings before it. The sun rose over vast forests of conifers and flowering plants, casting golden light across inland seas. Herds of Hadrosaurus moved in rhythm, their calls echoing through valleys as they grazed on fresh vegetation. Triceratops guarded their young, circling them in protective formations, horns glinting in the dawn. Predators waited at the edges, Tyrannosaurus rex lurking in the shadows of ferns, its keen eyes locked on movement within the herd. In the skies, pterosaurs soared on warm updrafts, gliding effortlessly above rivers and plains. Some dipped their beaks into the water to snatch fish, while others circled high, their shadows drifting over herds below. Smaller feathered birds flitted through the trees, their songs mixing with the constant hum of insects. The oceans mirrored this abundance. Ammonites spiraled in the shallows, their shells catching the light like living jewels. Mosasaurs patrolled the deep, their sleek bodies slicing through schools of fish that darted in frantic unison. Turtles paddled lazily between coral reefs, while plankton bloomed in the sunlit waters, feeding the cycle of life. To every creature alive, this day was no different from any other. Hunger, survival, mating, migration, these were the rhythms that guided existence. Even the predators, brutal and relentless, were part of a balance that had endured for millions of years. But above them, invisible to their eyes, destiny was racing closer. The first asteroid, the giant killer, was only minutes away from tearing through the atmosphere. The second, the Silent Partner, trailed in its wake, destined to follow with cruel precision. The first signs were subtle, easily missed by creatures that lived in the moment. A faint streak appeared across the blue sky, brighter than any star, moving faster than anything the Earth had ever known. To a triceratops grazing below, it was nothing, an unfamiliar glimmer that held no meaning. To the flocks of pterosaurs, it was just a streak of light above the clouds. But within seconds, that streak grew into fire. The asteroid compressed the air in front of it, turning the sky into a furnace. A blazing ball of heat and light screamed across the heavens, brighter than the midday sun. Shadows stretched long and sharp as forests lit with an eerie glow. Animals lifted their heads in confusion, some frozen in place, others breaking into sudden panic. The sound followed. First a low rumble, then a roar, louder than thunder, louder than volcanoes. Herds bolted. Hadrosaurs stampeded in terror, crashing through trees, their cries piercing the air. Predators abandoned hunts, their instincts overwhelmed by the unnatural noise. Even Tyrannosaurus, apex of the land, turned from prey and fled into the forests. In the oceans, creatures sensed vibrations rippling through the water. Ammonites recoiled into their shells. Mosasaurs shifted uneasily. Sharks darted with sudden urgency. The seas themselves seemed to shiver as the sky above split open. The asteroid descended faster than fear could travel. In less than a minute, it crossed from the edge of space to the surface of Earth. The light grew unbearable, searing the eyes of anything that looked upward. The air ignited, sending waves of heat that singed leaves and scorched feathers before the rock even touched the ground. And then came silence. For one fraction of a second, as the asteroid closed the last distance, the world seemed to hold its breath. The herds ran, the skies burned, the seas trembled. But in that instant, everything paused, as if waiting for the inevitable. When the impact came, it was beyond sound, beyond sight, beyond comprehension. The Earth itself convulsed as the giant killer struck, vaporizing stone and sea in a fireball that lit the planet. Mountains crumbled, forests flattened, and waves rose higher than skyscrapers. The sky turned to fire. And just as life reeled from this first blow, the second asteroid was still on its way. The dinosaurs could not have known it, but their final moments were written in the stars. Their world, so vibrant and alive, was about to vanish. The giant killer came first. It slammed into the shallow waters of what is now the Gulf of Mexico, and in that instant the world changed forever. A rock 10 kilometers wide, moving faster than sound, struck the Earth with energy equal to billions of atomic bombs. The sea around it vaporized instantly, transformed into a cloud of superheated steam and rock that shot upward with unstoppable force. The impact created a crater nearly 200 kilometers across, deeper than mountains are tall. Trillions of tons of Earth were hurled skyward, molten and glowing, carried into the upper atmosphere. Within seconds, a fireball larger than continents expanded from the point of collision. Everything within hundreds of kilometers, forests, rivers, dinosaurs, was gone, erased by heat and pressure. Shock waves radiated outward, tearing across the land. They flattened entire forests as though they were blades of grass. Winds faster than hurricanes howled outward, stripping trees of their leaves, lifting animals into the air, and throwing them across the landscape. To be anywhere within range of the impact was to face instant annihilation. The ocean responded with violence of its own. Waves taller than city skylines roared outward, tsunamis that raced across the seas at hundreds of kilometers per hour. Coastlines thousands of kilometers away would soon be swallowed by walls of water. Inland seas churned as if boiled from beneath, their ecosystems destroyed in moments. But while the world reeled from the first impact, the second was already descending. The silent partner, smaller yet still catastrophic, hurtled through the atmosphere with the same deadly speed. Where it struck remains debated, perhaps in Eastern Europe, perhaps in Asia. But wherever it landed, the effect was merciless. Its explosion added another crater to Earth's surface, smaller than Chicxulub, yet vast enough to obliterate life for hundreds of kilometers. Forests that had already been shaken and burned now fell again, consumed in fire and shock. Rivers boiled, lakes evaporated, and everything nearby was reduced to ash. The second asteroid's impact compounded the catastrophe. More rock was vaporized, more dust was blasted into the skies, more soot and ash joined the clouds already spreading around the globe. The atmosphere grew darker, heavier, deadlier. If Chicxulub had wounded the planet, the second strike deepened the injury, ensuring the extinction would not be partial but total. Together, the two impacts created a cascade of destruction that reached every corner of the world. Firestorms erupted across continents as molten debris rained down from the sky. Forests ignited in chain reactions, burning so fiercely that smoke circled the globe. Animals fled in terror, but there was no refuge. Flames consumed everything, leaving behind only blackened earth. In the oceans, tsunamis from both impacts collided, amplifying one another's force. Waves swept inland, drowning ecosystems and reshaping coastlines. Shallow seas became mass graves, filled with the remains of creatures that had once thrived. Ammonites, turtles, and fish were tossed like leaves in a storm, crushed against reefs and cliffs. Above, the sky itself turned against life. Dust and vapor rose into the stratosphere, spreading around the globe in a matter of days. Sunlight dimmed, replaced by a twilight that never lifted. Temperatures plummeted, as heat from the sun could no longer reach the surface. The once warm Cretaceous world began to freeze. The double collision marked the end of the dinosaurs' reign. It was not just the fire or the waves or the immediate destruction. It was the sequence, the overwhelming force of two blows arriving in rapid succession that ensured their extinction. Even creatures that might have survived the first impact found no chance after the second. And yet, the Earth itself endured. Though scarred and broken, it continued to spin, to orbit the sun, to hold the seeds of life in its wounded soil and seas. But the age of giants had ended in fire and silence, erased in the blink of geological time. While the Chicxulub asteroid unleashed devastation on a planetary scale, the second impact, the silent partner, brought its own brand of destruction. Smaller, less remembered, but no less catastrophic for the creatures that lived beneath its path. It struck Earth with violence that magnified the chaos already unleashed. Scientists still debate the exact site of the second impact. The Boltish crater in present-day Ukraine remains one of the strongest candidates, a scar measuring about 24 kilometers across. Though far smaller than Chicxulub, it was still immense, created by a rock perhaps 2 to 3 kilometers wide. In another time, another age, it would have been remembered as one of the greatest disasters in Earth's history. But its timing, coinciding with the death of the dinosaurs, ensured it became a shadow to Chicxulub's legend. Yet to the life around it, there was no shadow, only fire. The asteroid tore through the atmosphere with unstoppable momentum. Friction turned it into a blazing inferno, a ball of fire brighter than the sun. Forests below lit with eerie light as the sky screamed in protest. Then, in an instant, it struck. The ground erupted. Shock waves thundered through the earth, flattening everything in sight. Forests disintegrated, rivers exploded into steam, and the very crust of the planet split apart. Molten rock blasted upward, glowing shards of the earth itself hurled into the sky. A mushroom cloud of debris rose above the crater, a towering column of dust and fire that spread outward in every direction. The immediate destruction stretched for hundreds of kilometers. Herds of herbivores were incinerated before they could move. Predators collapsed under walls of fire in shock. Small mammals, birds, and reptiles were buried beneath collapsing trees and ash. No creature near the crater survived. But the devastation did not stop at the local scale. The second impact amplified the global catastrophe already unfolding from Chicxulub. More dust, more soot, more vaporized rock were added to the skies, thickening the shroud that blocked the sun. Fires ignited once more, spreading through forests that had only just begun to smolder from the first impact. Smoke darkened the atmosphere further, wrapping the world in twilight. Tsunamis joined the chorus of destruction. The smaller asteroids still displaced enough ocean to send waves racing across seas. Though dwarfed by the walls of water unleashed in Mexico, these tsunamis collided with those already traversing the globe, amplifying chaos. Coastlines shook under the relentless assault, drowning ecosystems that had survived the first wave. For the dinosaurs, the second strike was a death sentence layered atop a death sentence. Some herds may have survived Chicxulub's initial blast by sheer distance. They may have found shelter in valleys or clung to life in forests untouched by the first firestorms. But when the second asteroid struck, those fragile refuges vanished. Forests burned again, plains shook again, skies darkened further still. Survival became impossible. In the oceans, the effect was equally merciless. Plankton, already weakened by the sunlight lost after Chicxulub, now faced another influx of dust and ash. Without plankton, the marine food web collapsed. Ammonites, long survivors of previous mass extinctions, disappeared entirely. Great marine reptiles like mosasaurs and plesiosaurs starved, unable to find prey in dying seas. It was the sequence of catastrophes that mattered. Chicxulub had already broken the world, but the second strike ensured there would be no recovery. It was like a wounded creature struck twice, the first blow crippling, the second final. Yet the second asteroid left a quieter scar in human memory. Its crater, smaller and less dramatic, did not dominate history the way Chicxulub did. For millions of years, it lay hidden beneath sediments, erased from view. Only in the last few decades did science uncover its story, piecing together its role in the extinction. This silence is fitting. The second asteroid was never meant to be remembered by those who lived through it. Its purpose was not to leave a monument, but to erase, to ensure that the Cretaceous ended not in resilience, but in silence. And so, while Chicxulub burned the world, the silent partner sealed its fate. Together, they delivered a double blow so thorough that it ended one of the most successful dynasties in the history of life, the dinosaurs. After the earth shook, after the seas rose, after the craters yawned wide, a new terror followed. The sky itself caught fire. When the two asteroids struck, trillions of tons of molten rock were blasted high into the atmosphere. Fragments the size of houses and mountains were hurled into orbit before falling back through the air. Smaller particles, vaporized stone and glass, spread across the globe. As they rained down, the atmosphere turned into a furnace. Each fragment, no matter how small, entered the sky at incredible speed. Friction with the air heated them until they glowed like shooting stars. But this was no gentle meteor shower. It was a storm of fire. Billions of blazing fragments cascaded down at once, their combined heat overwhelming the planet's surface. Forests ignited spontaneously, not from direct contact, but from the sheer thermal radiation pouring from above. The world beneath the sky became an oven. Fires erupted everywhere. Conifer forests turned into infernos within minutes. Ferns and flowering plants shriveled and burst into flame. Herds of herbivores, already scattered in panic, were caught in waves of smoke and fire. Triceratops and hadrosaurs collapsed in the heat, their bodies consumed as flames swept across the plains. Predators fared no better. Tyrannosaurus, once supreme, fled before walls of fire that moved faster than it could run. Smaller creatures sought refuge underground or in burrows, but even there the heat penetrated. Smoke choked the air, ash settled thick, and the very ground seemed to radiate warmth. Rivers boiled, lakes steamed, and shallow seas evaporated into the inferno. The skies glowed a dim red, darker than day, yet brighter than night. A canopy of fire stretched horizon to horizon, blotting out the sun and moon. Creatures that looked upward saw no stars, no light of guidance, only a dome of flame. Insects, once abundant, perished in countless numbers, their delicate wings scorched by heat. Pterosaurs fell from the air, their wings alight. Birds, smaller and more resilient, managed to dart into pockets of safety, but many were lost. The air itself, once filled with calls and cries, became a storm of silence, broken only by the roar of fire. The oceans, too, felt the fury of the burning sky. Fiery debris struck the seas, vaporizing water and sending boiling plumes skyward. Coastal ecosystems roasted beneath showers of molten rock. Fish and marine reptiles fled deeper, but even the depths offered little refuge. Surface waters heated dramatically, killing plankton and disrupting the base of the marine food web. The fires were relentless. They did not simply burn forests and fields, they reshaped landscapes. Carbon from burned plants filled the air, adding to the thickening shroud of dust and ash already rising from the craters. Soot spread across continents, carried by winds that howled through burning lands. For days, the world burned. Nights were no darker than days, both lit by the constant glow of flames. Smoke turned skies a deep crimson, a twilight that never lifted. Rain did not fall as water, but as acid, carried down by chemicals released into the atmosphere. What survived the flames soon faced poison. And yet, amid the destruction, there were survivors. Small mammals huddled in burrows, feeding on roots and insects. Crocodilians retreated to waterlogged shelters, enduring heat that few others could withstand. Turtles buried themselves in mud and sand, waiting out the inferno. But their survival was not guaranteed, for the fires were only the beginning. The sky that had burned so bright would soon darken. Once the last fragments fell, once the last flames consumed the last forests, smoke and dust remained, and with it, sunlight itself began to fade. The reign of fire was short-lived, but its legacy was enduring. It stripped the earth bare, leaving only blackened wastelands where once lush forests thrived. It filled the air with soot that would linger, blocking the sun, chilling the world. The fires marked not the end of destruction, but the transition to a new phase of catastrophe, the long darkness to come. The dinosaurs, blinded and burned, did not know this. They only knew the sky had betrayed them, raining fire where once it had given light. And in that betrayal, their world slipped further into silence. When the asteroids struck, they did not only scar the land and ignite the sky, they shook the oceans themselves, unleashing waves taller than mountains, tsunamis of unimaginable scale. The Chicxulub impact alone struck in shallow seas, displacing unimaginable volumes of water. In an instant, the Gulf of Mexico heaved upward, its waters thrown high as the asteroid bored into the crust beneath. Walls of water hundreds of meters tall raced outward in all directions. Coastlines thousands of kilometers away were doomed before the waves even formed. Their fate sealed the moment the rock struck. Ships, had they existed, would have been tossed aside like leaves in a storm. The first wall of water moved faster than the fastest animal could flee. It swept over shorelines with unstoppable force, stripping forests, scouring plains, and burying everything beneath mud and debris. But this was only the beginning. As the second asteroid struck, it too displaced oceans and lakes, raising new waves that joined the chaos. The timing of the two impacts meant that tsunamis overlapped, colliding with one another, amplifying their height and strength. Entire inland seas surged violently, their waters drawn into massive oscillations that destroyed everything along their shores. In North America, waves surged deep into the interior. Vast inland seas, already connected to the Gulf, magnified the destruction. Coastal plains became submerged beneath roiling water, drowning dinosaurs and herds of hadrosaurs that had grazed on fertile lowlands. Trees were ripped from their roots, carried for kilometers before being buried in layers of sediment. In South America, coastlines collapsed under the weight of the water. Beaches became graveyards of shattered life. The bodies of marine reptiles tossed ashore in heaps. In Europe and Asia, waves triggered by the second impact surged along continental shelves, flooding estuaries and forests alike. No coast was untouched. The force of these tsunamis was unlike any modern storm. Entire forests vanished in moments, replaced by swirling seas filled with mud, shattered coral, and the remains of creatures torn apart by the violence. Mosasaurs and plesiosaurs, though masters of the oceans, could not withstand the chaos. The waves smashed them against reefs and cliffs, tearing their bodies apart. Ammonites, delicate and numerous, were destroyed in untold billions, their coiled shells ground to dust in the churning water. Sediments carried by these tsunamis buried everything in their path. Layers of mud, silt, and sand settled over coastlines, fossilizing the last moments of life. In places, these layers remain today, silent witnesses to the waves that once reshaped the continents. The scale of destruction extended far inland. Valleys filled with rushing water, rivers reversed their flow, and plains became seas in a matter of minutes. Dinosaurs caught in the flood stood no chance. Herds of triceratops and ankylosaurs were swept away, their massive bodies carried like driftwood. Predators fared no better. Even Tyrannosaurus, heavy and powerful, was powerless against walls of water that rose higher than any tree. The tsunamis also carried death in subtler forms. When they receded, they left behind devastation. Salty sediments that poisoned soils, stagnant pools where disease flourished, and landscapes stripped bare of vegetation. Survivors who escaped drowning soon faced famine and disease in the aftermath. The psychological impact on the natural world would have been as profound as the physical. For animals accustomed to cycles of rain and drought, flood and growth, this was no ordinary storm. The familiar was erased, replaced by alien landscapes where land became sea and sea became wasteland. And yet, the tsunamis were only one part of a greater chain reaction. While water drowned the lowlands, fire consumed the forests, and ash darkened the skies. The combined assault left no corner of the planet untouched. The waves themselves eventually settled. Days later, the seas calmed, and the coastlines reformed. But what remained was not the world that had existed before. It was a wasteland of mud and ruin, stripped of its richness, devoid of its forests, littered with the carcasses of creatures too large to bury. In the silence that followed, the tsunamis left their legacy not in sound or sight, but in memory, recorded in the rocks, etched into the layers of sediment, preserved as evidence of the day the oceans themselves rose to destroy the world. And for the dinosaurs, those waves marked one more hammer blow in a cascade of destruction that would not end until their reign was no more. When the asteroid struck, the violence did not stop at the surface. The energy they unleashed tore through the crust, rattling the planet to its core. Mountains quaked, continents trembled, and deep beneath the surface, the Earth itself groaned in pain. The Chicxulub impact released energy equivalent to more than 100 million megatons of TNT. The shock wave that rippled outward was not confined to the air or the oceans. It penetrated solid rock, traveling through the crust as seismic waves. Within minutes, earthquakes shook the land thousands of kilometers from the crater. Forests swayed violently, rivers shifted course, and landslides cascaded down mountainsides. In North America, the ground convulsed with a fury never seen before. Fault lines slipped, releasing additional energy as the planet's crust adjusted to the sudden blow. In South America and beyond, the tremors continued, a rolling reminder that no place was beyond the asteroid's reach. The second impact amplified the chaos. Though smaller, it still unleashed quakes of staggering magnitude. Combined, the two strikes set off a chain reaction of seismic unrest. Entire regions shifted in moments, landscapes reshaped in hours. Volcanoes felt the shock. In distant India, the Deccan traps were already active, vast eruptions pouring lava across the subcontinent. The impacts may have intensified this outpouring, shaking magma chambers and opening new fissures. Rivers of molten rock spread for thousands of square kilometers, releasing carbon dioxide and sulfur dioxide into the air, adding poison to skies already darkened with dust and soot. In the Pacific, tectonic plates strained against one another, their slow dance accelerated by the impact's seismic energy. Subduction zones groaned under sudden stress, sending aftershocks across the ocean. Islands shifted, coastlines collapsed, and the seafloor cracked open, releasing bursts of heat and gas. The sheer violence of the impacts altered tides and currents. The gravitational pull of the moon and sun continued as usual, but the oceans themselves sloshed in unnatural rhythms, disturbed by the shaking of the crust. Inland seas became unstable, their waters surging unpredictably as the ground beneath them buckled. For the dinosaurs, these earthquakes were incomprehensible. Herds accustomed to storms and floods found themselves on trembling earth that gave no solid footing. Forests fell not just from fire or flood, but from the shaking ground itself. Cliffs crumbled, burying creatures beneath tons of rock. Even those that had escaped fire and water were crushed by collapsing landscapes. In caves and burrows, small mammals and reptiles faced their own terrors. The very shelters that had protected them from flames now threatened to collapse, burying them alive. Yet these same creatures, by chance and resilience, would prove among the few to endure. The planet shuddered for days. Aftershocks followed the initial quakes, rumbling across continents. The ground seemed restless, unstable, as though rejecting the violence forced upon it. Each tremor unsettled survivors further, stripping away any chance of stability. The impacts also reached deeper into the mantle. Some scientists believe shock waves may have disrupted circulation within Earth's interior, triggering volcanic activity that persisted for hundreds of thousands of years. The Deccan traps, already spewing lava, may have intensified their eruptions in the aftermath. Gases from these eruptions, sulfur, carbon dioxide, methane, only worsened the global climate crisis. For the biosphere, the combined assaults of fire, water, and shaking earth created a total war. Nowhere was safe. No refuge remained untouched. Animals that fled firestorms found themselves drowned by tsunamis. Those that escaped the waves were trapped by landslides or poisoned by volcanic gases. Those that hid in burrows endured earthquakes and collapsing ground. The earth itself became the enemy. And yet, within this chaos, life endured in fragments. Some crocodilians, adapted to survive in rivers and lakes, outlasted the quakes by remaining in water. Some mammals, small and resourceful, clung to survival in underground networks that miraculously held. Seeds buried in soil withstood fire and flood, waiting for sunlight that would one day return. But in the immediate aftermath, the planet was broken. Continents shifted, coastlines redrawn, and volcanoes belched new layers of poison into skies already suffocating. The impacts had not only scarred the surface, they had shaken the very foundations of Earth. And in that trembling silence, the dinosaurs' world grew darker still. After the fire, after the waves, after the Earth itself shuddered, a deeper catastrophe unfolded. The skies, once blazing with sunlight, grew dim, then black. The world entered a long night, a nuclear winter of the Cretaceous. The impacts had thrown trillions of tons of dust, ash, and soot into the atmosphere. Particles from vaporized rock, carried high into the stratosphere, spread around the planet within days. They were joined by smoke from global wildfires and gases from volcanic eruptions triggered by the quakes. Together, they created a shroud that wrapped the Earth, blotting out the sun. Daylight vanished. What had once been a bright and warm world became locked in twilight. The sun appeared only as a faint reddish disk, filtered through layers of dust. In many places, it disappeared entirely. For months, perhaps years, the world knew no true day. The loss of sunlight struck at the heart of life. Plants, the foundation of every ecosystem, withered. Without light, photosynthesis faltered. Forests already burned by fire could not regrow. Ferns, flowering plants, and conifers all struggled in the endless night. In the oceans, plankton died in vast numbers, collapsing the base of the marine food web. Temperatures plummeted. Without sunlight to warm the surface, the Earth cooled dramatically. Regions once lush and temperate froze. Winters grew harsher. Summers vanished into gray cold. Creatures adapted to warmth, the dinosaurs most of all, found themselves in a world suddenly hostile to their very existence. For the survivors, the struggle was relentless. Herbivores starved first. Without plants to eat, herds of hadrosaurs and ceratopsians weakened, collapsing in masses. Predators followed, their prey gone. Tyrannosaurs that once ruled the land turned desperate, scavenging carcasses, fighting each other for scraps. Even their dominance could not withstand famine. In the oceans, mosasaurs and plesiosaurs found the seas empty of food. Ammonites, once abundant, dwindled to extinction. Fish populations crashed as plankton disappeared. Sharks and marine reptiles, once kings of the seas, starved in waters that had turned barren. The air grew toxic. Soot and sulfur particles mixed with water vapor to create acid rain, burning leaves and poisoning lakes. Creatures that drank from these waters fell sick. Soils turned sour, further preventing regrowth. The Earth's biosphere was under siege from every direction. The darkness was not complete everywhere. In some regions, faint light filtered through, enough to sustain patches of resilient plants. Ferns, hardy and adaptable, emerged first in the fossil record, colonizing burned landscapes once the dust began to thin. But for years, these green shoots were rare, and the animals that might have fed on them were already gone. Small creatures had the best chance. Mammals, no larger than rats, survived on roots, insects, and seeds. Crocodilians, capable of fasting for months, endured in rivers and swamps. Turtles buried themselves in mud, waiting for warmth to return. Birds, descended from small dinosaurs, managed to outlast the catastrophe by eating seeds and insects. But for the great dinosaurs, there was no escape. Their massive bodies required vast amounts of food, and the food was gone. Their long reign ended not in fire alone, but in famine, silence, and cold. The nuclear winter may have lasted years. Temperatures dropped by as much as 10 to 15 degrees Celsius globally, an enormous shift in climate. Seasons blurred into a single endless chill. Storms became violent, driven by atmospheric chaos. Rains carried soot, coating the land in black sludge. Slowly, over time, the dust began to settle. Larger particles fell first, then smaller ones. Winds spread them evenly across the globe, creating the thin layer of clay that scientists would one day discover in rocks everywhere. This iridium-rich band, no thicker than a coin, is the fingerprint of extinction, the evidence of the day the sky turned against life. But by the time the skies cleared, the damage was done. Ecosystems were shattered, species erased, landscapes unrecognizable. The nuclear winter of the Cretaceous had ended the age of dinosaurs, leaving behind only a handful of survivors to rebuild the world. For millions of years, the Earth had basked in warmth, sunlight, and abundance. But in the span of days, it was cast into cold and darkness. The nuclear winter was the final hammer in a sequence of blows. It did not strike with the violence of the impacts, the fury of the waves, or the roar of fire. Instead, it struck with silence, starvation, and time. The dinosaurs, magnificent rulers of their age, had no chance against a sky that refused to shine. And in that endless twilight, their chapter in the story of life came to its close. Every ecosystem rests on a foundation, and in the late Cretaceous, that foundation was plants. The forests of conifers, the sprawling ferns, the flowering plants that had spread across the continents, they were the engines of life. They captured the sun's energy and transformed it into food. From them, the great chains of survival extended outward, feeding herbivores, then predators, then scavengers, linking every creature in an intricate web. When the asteroid struck and sunlight vanished, that web began to unravel. The first to fall were the plants themselves. Without sunlight, photosynthesis slowed, then ceased. Leaves shriveled, seeds failed to sprout, and forests once rich with life turned into skeletal remains. The global fires had already burned vast swaths of vegetation, but the darkness prevented regrowth. The Earth's surface became a barren wasteland of charred trunks and withered foliage. With the plants gone, the herbivores faced starvation. Hadrosaurs, those duck-billed grazers that had once roamed in herds numbering in the thousands, struggled to find food. They had survived fire and flood, but famine was merciless. Their stomachs, built to process massive quantities of leaves and stems, found only ash and dust. Weakened, they collapsed in droves, their herds dwindling with each passing day. Ceratopsians, like the mighty Triceratops, fared no better. Their beaks, sharp and powerful, were useless against a world without greenery. Once proud herds became scattered groups of starving survivors, their horns and frills serving no purpose in a land where combat no longer mattered. Ankylosaurs, armored tanks of the Cretaceous, could not outlast the famine either. Their bulk required fuel, and the fuel was gone. With the herbivores dying, the predators were next. Tyrannosaurus rex, apex hunter of its age, turned to scavenging. It followed herds of the dying, tearing into carcasses when it could find them. But even the kings of the land could not endure long in a world where food sources vanished faster than they appeared. Smaller predators like dromaeosaurs, once swift and deadly hunters, starved just as quickly. Their agility and intelligence could not overcome famine. The collapse rippled outward. Scavengers, which depended on the remains left behind by predators, found fewer and fewer carcasses. Insects that fed on dung and carrion dwindled. The intricate cycles of recycling life into soil faltered. The earth itself seemed to stop breathing. In the oceans, the collapse was equally merciless. Plankton, the invisible foundation of marine life, died without sunlight. These microscopic plants fed small fish and filter feeders, which in turn supported larger predators. When the plankton vanished, the entire marine ecosystem crumbled. Ammonites, spiraled icons of the seas, disappeared forever. Their long resilience through past extinctions came to an end. Mosasaurs and plesiosaurs, apex predators of the oceans, starved as their prey dwindled. Sharks and large fish struggled, their populations crashing. Even reefs, once teeming with life, became barren wastelands as corals bleached and died. The collapse of the food web was not immediate. It unfolded over weeks, months, and years. At first, some species endured by feeding on the last remnants of vegetation or carrion. But the cycle could not sustain itself. One by one, links in the chain snapped, and each collapse brought others down. The dinosaurs, for all their size and power, were the most vulnerable. Their massive bodies demanded constant fuel. Unlike small creatures that could hide, burrow, or slow their metabolisms, the giants had no fallback. Famine cut them down as surely as fire or flood. And yet, not everything perished. Mammals, small and adaptable, found ways to survive. They scavenged seeds, roots, and insects, eking out an existence in the shadows. Crocodilians endured in swamps and rivers, their ability to slow their metabolisms giving them an edge. Turtles, hidden in mud, outlasted the famine. Birds, the last of the dinosaurs, survived by feeding on seeds and insects, carrying their lineage into the new age. But for the great dinosaurs, the food web's collapse was the final blow. The hadrosaurs, triceratops, ankylosaurs, and tyrannosaurs that had once dominated the land vanished. The mosasaurs, ammonites, and plesiosaurs that had ruled the seas followed. The sky emptied of pterosaurs, leaving only birds to inherit the air. The collapse of the food web was more than the end of species. It was the end of a world. The balance that had endured for millions of years, that had allowed dinosaurs to flourish in such abundance, was gone. It was not destroyed by slow change or gradual decline, but ripped apart in a cascade of extinction, triggered by two wandering rocks from space. In the silence that followed, the Earth became a graveyard. Forests lay blackened, oceans lay barren, plains lay empty. The once thundering herds were gone, replaced by stillness. The mighty food web that had bound life together for ages was broken, leaving only fragments. And yet, in those fragments, the seeds of the future remained. The world that the dinosaurs had known for over 150 million years was gone. The lush forests, the fertile plains, the warm inland seas, all had been transformed into wastelands of ash, mud, and silence. Yet even as famine deepened and skies remained shrouded in darkness, small pockets of life lingered. And within those fading pockets, the last dinosaurs drew their final breaths. Imagine a triceratops herd moving through a devastated plain. Once they had marched proudly, horns lifted against predators, frills gleaming in the sun. Now they stumbled weakly across barren ground, their ribs visible beneath their hides, their steps sluggish. Young calves, once protected fiercely at the center of the herd, fell behind, unable to keep up. One by one they collapsed, and the herd pressed on, too weakened to defend or mourn. Tyrannosaurus still roamed, but it was no longer the lord of the land. Hunger had stripped it of strength, forcing it to scavenge among carcasses. Its once thunderous roar had grown hoarse. Even its dominance meant nothing in a world without prey. Desperate, it turned against its own kind, scavenging the bodies of fallen tyrannosaurs, or clashing with rivals over scraps. These kings of the Cretaceous ended not in triumph, but in bitter struggle, fighting each other for the last remnants of life. Ankylosaurs, armored giants, once unstoppable, now moved slowly across wastelands with no plants left to eat. Their tail clubs, once symbols of power, dragged uselessly behind them. Many fell simply from exhaustion, their armor serving as nothing more than a shell around starving bodies. Hadrosaurs, the great herding grazers, faced an especially cruel fate. Their herds had once filled valleys with sound, their calls echoing for kilometers. Now those calls faded into silence, as herds shrank from thousands to dozens, from dozens to none. Their social bonds remained until the end. Mothers still stood over their calves, even as both starved together. The skies, once alive with pterosaurs, had grown empty. The great asdarchids, with wingspans larger than small planes, could no longer find food along coastlines stripped of life. One by one, they fell from the air, their wings folding for the last time. Only the smallest birds endured, their diets flexible enough to sustain them. The oceans, too, reflected this pattern of lingering survival and collapse. Mosasaurs still patrolled, but their prey was gone. Once sleek and powerful, they became thin, their movements sluggish, their hunts desperate. When they surfaced, they revealed bodies worn by famine, their reign of the seas reduced to slow death. Ammonites, which had survived countless extinctions before, vanished forever in these final days. Their spiral shells, once abundant, became relics buried in sediment. For the last dinosaurs, the struggle was not sudden but drawn out. Each day was a test of endurance. Each night, a quiet battle against hunger and cold. Predators prowled not for dominance but for survival, scavenging where they could, attacking weakened prey with diminishing energy. Herbivores wandered endlessly, searching for plants that no longer grew. Storms swept across the land, fueled by chaotic climates in the aftermath of the impacts. Acid rain fell on weakened creatures, burning their hides and poisoning their waters. Ash coated the ground, clogging mouths and throats. In some regions, temperatures dropped to freezing levels, killing dinosaurs that had never adapted to cold. Some may have retreated to valleys or sheltered forests, tiny refuges where ferns sprouted briefly or where streams still carried water. Here, the last communities of dinosaurs held on. But isolation was not salvation. Cut off from herds, vulnerable to predators, they dwindled. Calves grew without food, predators fought for scraps, and each refuge became a slow grave. The extinction was not absolute in a single moment. Rather, it was a cascade of endings spread across years. But the direction was certain and the outcome inevitable. Every species of non-avian dinosaur would vanish, leaving only their smaller bird descendants to carry their legacy. And so the final days of the dinosaurs were marked not by battles of glory, but by silence. Herds no longer thundered across plains. Roars no longer echoed through forests. Wings no longer shadowed the ground. The last Tyrannosaurus, the last Triceratops, the last Ankylosaur, they all fell not to predators, but to famine, to cold, to a world that no longer supported them. Their extinction was not simply the end of an age. It was the end of a way of life that had endured for longer than humanity can imagine. For over 150 million years, dinosaurs had been the dominant forms of life on land. They had survived earlier extinctions, adapted to shifting continents, thrived in climates hot and cold. But they could not survive the sky itself turning dark. And when the last of them fell, the earth entered a new silence. Yet this silence was not final. For small creatures endured, mammals in their burrows, crocodilians in their rivers, birds in their shelters. From them new life would rise. But for the great dinosaurs, the final days were marked by hunger, cold, and the quiet closing of their age. Amid the fires, the floods, the earthquakes, and the darkness, not all life vanished. While the dinosaurs, pterosaurs, ammonites, and mosasaurs fell into silence, other creatures clung to existence. Their survival was not guaranteed, nor was it easy. It was a gamble played against impossible odds, and only a handful succeeded. The survivors were not the largest, the strongest, or the most fearsome. They were the adaptable, the resourceful, the ones capable of enduring famine and cold. In this, the apocalypse rewarded not power, but resilience. Mammals were among the greatest winners of this gamble. Before the impacts, they had lived in the shadows of the dinosaurs, small, nocturnal, often overlooked. Their lives had been defined by caution, by hiding in burrows, by scavenging seeds and insects. But these habits became their salvation. When firestorms swept the land, mammals retreated into underground tunnels, safe from the searing heat. When famine struck, their varied diets allowed them to eat what others could not: roots, fungi, seeds, carrion. When the skies darkened, their small bodies required less food, and their fast reproductive cycles allowed populations to recover more quickly. While dinosaurs fell because of their enormous needs, mammals endured because of their modest ones. Crocodilians survived too, their fate tied to the water. Adapted to ambush and patience, they could slow their metabolisms to survive long stretches without food. In rivers and lakes, they sheltered from fire and cold. Their thick hides protected them. Their aquatic habits insulated them from many surface disasters. Though many populations declined, enough endured to carry their lineage into the new age. Turtles, with their protective shells and burrowing instincts, endured by retreating into mud and sand. Many could hibernate through the cold, surviving long periods without nourishment. As herbivores, they benefited from seeds and hardy plants that managed to regrow even in the faint twilight. Their ability to retreat and wait gave them an edge when larger creatures perished. Birds, descendants of small theropod dinosaurs, carried the lineage of their cousins into the future. Their survival hinged on flexibility. Many could eat seeds, which survived the fires and darkness better than living plants. Some scavenged insects or small animals, exploiting niches left vacant by extinction. Though the great pterosaurs fell, birds endured, and in time they would diversify into one of the most successful groups on Earth. Amphibians like frogs and salamanders also endured. Their reliance on damp habitats, combined with the ability to burrow and slow their metabolisms, shielded them from the harshest effects. While many species perished, enough survived to repopulate wetlands once the Earth recovered. It was not just animals. Certain plants also made the gamble and won. Ferns, hardy pioneers, flourished in the aftermath. In fossil records, a fern spike marks the regrowth that followed the extinction. Forests burned to ash sprouted again with carpets of ferns. These plants, capable of thriving in disturbed soils and dim light, reclaimed the land when others could not. Seeds too played a role. Buried underground, insulated from fire and cold, they endured the darkness until sunlight returned. When they sprouted, they provided the first food for surviving herbivores and omnivores. The survivor's gamble was not simply endurance of catastrophe, but adaptation to change. Those that lived through the extinction emerged into a world transformed. Predators were gone, freeing new niches. Competition was reduced, allowing survivors to expand. The collapse of the dinosaurs cleared the stage, and those that had once lived in shadows now found themselves in the light. Mammals, in particular, seized this opportunity. Once no larger than rats or possums, they spread rapidly in the absence of dinosaurs. Some grew larger, some diversified into new forms, experimenting with ways of life that had been impossible before. Their gamble, their endurance through the extinction, would one day lead to primates and, eventually, to humans. But survival came at a cost. Populations were small, species counts reduced, ecosystems stripped bare. The survivors emerged into a quiet, empty world, one that would take millions of years to recover. The gamble was not one of triumph, but of persistence, a desperate endurance that carried them through when giants fell. For the dinosaurs, the end was extinction. For mammals, crocodiles, turtles, birds, and amphibians, the end was a beginning. Their gamble had paid off, and from their survival, the next chapter of life would be written. And so, while the age of dinosaurs closed in silence, the survivors' gamble ensured that life itself endured. Fragile, battered, reduced, but alive. And in that survival lay the seeds of everything that would follow. When the firestorms ended, when the waves receded, when the darkness finally began to lift, the earth lay in ruins. The age of dinosaurs was gone, their bones buried in ash and mud. The skies were gray, the forests were blackened stumps, and the oceans were empty graveyards. But life is resilient. Even in the wake of destruction, it stirs, adapts, and rises again. The rebuilding of Earth began quietly, invisibly. Seeds buried in the soil sprouted when the dust thinned and faint sunlight returned. Ferns were the first to reclaim the land. Hardy and fast-growing, they thrived in disturbed soils, covering vast landscapes with green carpets. Paleontologists call this moment the fern spike, a clear signal in the fossil record of a world renewing itself. These fern fields spread across continents, replacing the once towering forests of conifers and flowering plants. Though simpler, they provided food and shelter for the survivors. Insects returned to feed on their fronds. Small mammals scurried among them. Birds plucked seeds and nested in their shadows. Life began to weave new connections, new food webs rising from the ashes of the old. As centuries passed, flowering plants slowly returned. Seeds that had survived in the ground or within the stomachs of birds began to sprout. Forests regrew, first with shrubs and small trees, then with towering canopies. The devastation had cleared space for experimentation. Plant life diversified in ways it never had before, filling niches left vacant by extinction. The oceans, too, began their slow recovery. Plankton returned when sunlight filtered back into the surface waters. Their tiny cells multiplied, forming the foundation of new marine food chains. Small fish followed, then larger predators. Reefs slowly rebuilt themselves, though much of their ancient richness was lost. The seas would never again look exactly as they had in the time of mosasaurs and ammonites, but they grew vibrant once more. With plants reclaiming the land and plankton filling the seas, animals found opportunities to expand. Crocodilians thrived in rivers and swamps, their bodies unchanged, their strategies timeless. Turtles spread into new habitats, their shells a shield of continuity in a changing world. Amphibians reoccupied wetlands, their croaks returning to the night air. But it was the mammals and birds that began to shape the future. Freed from the shadow of dinosaurs, mammals grew larger, more diverse. Some evolved into new predators, others into grazers, climbers, and burrowers. Within millions of years, their descendants would include hoofed animals, primates, and whales. Birds, too, diversified, filling the skies left empty by pterosaurs. They grew into raptors, waterfowl, songbirds, and more. Their beaks and wings adapted to countless new niches. The rebuilding of Earth was not rapid. It took hundreds of thousands of years for forests to regrow, millions for biodiversity to return to pre-extinction levels. But compared to the silence of the apocalypse, the recovery was swift. Ecosystems rebuilt, species adapted, and life flourished once again. Yet the scars remained. The dinosaurs did not return. Ammonites never reappeared. Mosasaurs and plesiosaurs remained forever gone. Extinction is permanent, and the world that rose after the catastrophe was not the same as the one that came before. It was a new Earth, with new rulers, new forms of life, and new possibilities. From destruction came opportunity. The rebuilding allowed mammals to step into roles that dinosaurs had once dominated. The absence of great reptiles opened the path for mammals to grow in size and complexity. Eventually, this would lead to the rise of primates, and much later, to humans themselves. The rebuilding of Earth after the double impact shows a truth that stretches across all of history. Life endures. It bends, it adapts, it suffers, but it continues. Mass extinctions are not the end, but the beginning of something new. They reset the stage, and in the silence that follows, evolution writes a different play. The dinosaurs' reign ended in fire and darkness. But from that silence, the survivors built a new world. Earth, scarred but alive, carried on. For 150 million years, dinosaurs had defined life on land. Their footsteps shook the earth. Their herds thundered across plains. Their predators ruled with unmatched power. Then, suddenly, they were gone. The world that remained was a shadow of what it had been, a planet stripped of its giants. In their absence, a new chapter began. The silence was immediate and profound. Where once valleys echoed with the cries of hadrosaurs, now there was only wind. Where Tyrannosaurus once roared, now there was only stillness. The skies, once crowded with pterosaurs, were quiet except for the flutters of small birds. The oceans, once filled with ammonites and mosasaurs, felt emptier than ever before. But the extinction of the dinosaurs was not the end of life. It was a reshaping, a clearing of the stage. And in that emptiness, the survivors began to expand. Mammals, long confined to the shadows, now found themselves free. Before the extinction, they had been small, nocturnal, cautious. They had hidden from dinosaurs, scurrying through forests at night, feeding on insects and seeds. Now, without the constant threat of predators and competition, they began to grow. In the first few million years after the extinction, mammals diversified rapidly. Some evolved into grazers, feeding on the regrowing plants. Others became hunters, filling niches left behind by vanished predators. Within 10 million years, mammals ranged from tiny shrew-like creatures to beasts the size of bears. Their forms multiplied, their adaptations spread across every environment. The absence of dinosaurs had opened the door, and mammals walked through it. Birds, too, flourished. Once overshadowed by the great pterosaurs, they inherited the skies. Their beaks and wings diversified into countless shapes. Some became hunters of fish, others grazers of seeds, still others masters of song. In time, they would spread into every corner of the planet, from forests to oceans to deserts. The reptiles that survived also thrived in their own ways. Crocodilians, already ancient by the Cretaceous, continued their reign in rivers and swamps. Turtles spread across continents and seas, their shells unchanged, but their reach expanded. Snakes, which had already begun to evolve before the extinction, found opportunities in a world less crowded with giant predators. The plants, too, changed. With forests destroyed, ferns had been the first to return. But as time passed, flowering plants reclaimed dominance. They grew into vast forests, filling the planet with diversity of form and color. Grasses, still primitive in the Cretaceous, began to spread, setting the stage for the great grasslands that would one day support herds of mammals. Earth itself became quieter, less dominated by giants, but more open to variety. Ecosystems were rebuilt on smaller scales, less imposing but more intricate. The world no longer belonged to a handful of massive rulers, but to countless smaller survivors. Yet the absence of dinosaurs was felt everywhere. For millions of years, their bones lay scattered across plains, buried in mud, reminders of an age of power that had passed. Mammals walked among those bones, inheritors of a world shaped by the destruction of giants. Birds flew over the fossilized remains of their own cousins, carrying forward a lineage that had barely survived. A world without dinosaurs was not only a biological change, it was an ecological revolution. It reshaped the future of evolution itself. Without dinosaurs consuming vast resources, ecosystems reorganized. Without tyrannosaurs at the top of the food chain, new predators emerged. Without hadrosaurs and ceratopsians grazing in massive herds, new forms of herbivores arose. Over tens of millions of years, this new world became unrecognizable compared to the Cretaceous. Mammals grew into titans of their own, the massive indricotheres, the towering mammoths, the armored glyptodons. Birds evolved into predators like the terror birds of South America, towering over humans who would one day encounter their fossils. Life experimented with forms and strategies in the freedom left by extinction. But it all began in silence, in the first years after the impacts, when Earth was emptied of giants. A world without dinosaurs was a world of survivors. It was a world where adaptability triumphed over size, where patience outlasted power. The dinosaurs had ruled in strength, but their extinction proved that survival is not about dominance. It is about resilience. And from that resilience, from mammals, birds, reptiles, and plants, a new Earth rose. It would never again be the world of the dinosaurs, but it would become the world that led, eventually, to us. The story of the dinosaurs' extinction has long been told as the tale of a single rock from space, the Chicxulub asteroid, the giant killer, striking Mexico's shallow seas and ending an age. For decades, this explanation stood as fact, but science is rarely so simple. With every new discovery, with every new layer of evidence, the story has deepened. Today, many believe the catastrophe may not have been a solitary strike, but a 1-2 blow, a double impact that sealed the dinosaurs' fate. The idea of multiple impacts first surfaced when scientists began examining global rock layers at the boundary between the Cretaceous and Paleogene, known as the KPG boundary. Everywhere they looked, they found signs of catastrophe. A thin band of clay enriched with iridium, a metal rare on Earth but common in asteroids. Shocked quartz, tiny grains scarred by unimaginable pressures, lay mixed in with the clay. Spherules of glass, formed when rock was vaporized and then cooled, were scattered across continents. All these pointed to an asteroid. But in some sites, the evidence hinted at more than one. The Chicxulub crater was undeniable. Buried beneath Mexico's Yucatan Peninsula, it measured nearly 200 kilometers across, its shape preserved beneath layers of younger rock. Drilled cores revealed melted stone and minerals that could only have formed in the heat of an impact. It was the smoking gun, the site of the Great Extinction. Yet across the world in Ukraine lay another scar, the Boltish crater. Smaller, only about 24 kilometers across, it was still immense by human standards. When scientists first studied it, they believed it was younger than Chicxulub, perhaps by hundreds of thousands of years. But as dating techniques improved, the story shifted. The Boltish impact may have happened at nearly the same time as Chicxulub, separated by no more than tens of thousands of years, or possibly even less. To geologists, tens of thousands of years is a blink, a heartbeat of Earth's history. The possibility that both impacts happened during the same extinction event began to grow. Some suggested that Boltish may have been part of an asteroid family, fragments of a larger body broken apart long before, their orbits carrying them into Earth's path together. Others wondered if Earth had encountered a binary asteroid system, two rocks locked together, striking the planet in sequence. Evidence beyond craters also supports the idea. Layers of ejecta, the spherules of glass and shocked minerals, show signs of multiple deposition events. In some sites, there appear to be two distinct layers separated by thin bands of sediment, as if two impacts had showered the planet at different times. The chemical signatures of these layers also vary, suggesting they came from more than one impact source. Still, the theory is debated. Some argue that Boltish formed too late to play a role in the extinction, occurring after the worst was already over. Others believe its effects, though catastrophic locally, were minor compared to Chicxulub's global devastation. Yet the evidence continues to build, and many paleontologists now believe the extinction may have been hastened or intensified by multiple strikes. The double impact theory also helps explain the thoroughness of the extinction. Chicxulub alone could have caused global catastrophe, But why did extinction rates soar so absolutely? Why did even resilient groups like ammonites vanish when they had survived past crises? Perhaps the second asteroid was the final push, arriving when ecosystems were already shattered, ensuring recovery was impossible. Modern technology continues to unravel the mystery. Radiometric dating of impact glass, high-resolution stratigraphy of rock layers, and computer simulations of asteroid dynamics all sharpen the picture. The more precise the data becomes, the more the window between the two impacts seems to narrow. But for all our science, much remains uncertain. We may never know exactly where the second asteroid struck, or precisely how close in time it came to Chicxulub. What is clear is that the Earth bears more than one scar from that age, and the story of extinction may be more complex than a single blow. To the dinosaurs, the details did not matter. They did not know whether one asteroid or two had come. They only knew fire, flood, and famine. But for us, unraveling the double impact theory is more than a question of history. It is a reminder of how fragile life can be, how easily a world can change, how quickly dominance can end. The dinosaurs ruled for millions of years, yet their reign ended in days, perhaps even hours, under the weight of the cosmos. And whether it was one strike or two, the lesson remains the same. The universe is vast, unpredictable, and indifferent to power. In the end, the double impact theory does not replace Chicxulub's story. It enriches it. It shows us that extinction is rarely simple, that catastrophe often comes in layers, and that survival is shaped not only by chance, but by the cruel timing of fate. 66 million years ago, two wanderers from the void struck Earth with unimaginable force. They ended the age of dinosaurs, erased entire ecosystems, and plunged the planet into fire and darkness. Yet from that destruction came rebirth. The legacy of those impacts is not only one of loss, but also one of transformation. Without them, the story of life and humanity itself would be entirely different. The immediate legacy was silence. The thundering herds of hadrosaurs, the roars of tyrannosaurs, the wing beats of pterosaurs, all were gone. Ammonites no longer spiraled through the seas, and mosasaurs no longer patrolled the deep. The skies, once crowded with giants, became open. The extinction was absolute, reshaping every ecosystem on the planet. But in the void left behind, survivors rose. Mammals, once no larger than rats, flourished. Freed from the shadow of dinosaurs, they diversified into new forms: grazers, predators, climbers, swimmers. Within a few million years, they filled the niches once dominated by reptiles. Crocodiles, turtles, and amphibians continued their ancient reigns, steady as they had been for hundreds of millions of years. Birds inherited the skies, evolving into one of the most diverse groups of animals ever to exist. Plants, too, reshaped the earth. Flowering plants spread across continents, carpeting the land in colors unseen in earlier ages. Grasses evolved and spread, paving the way for vast grasslands. These new landscapes would one day host herds of mammalian giants, mammoths, bison, horses. But it all began with recovery after extinction. The long-term legacy was opportunity. The double impacts cleared the stage for evolution to experiment, to try forms that had been suppressed in a dinosaur-dominated world. It allowed mammals to grow larger, to develop intelligence, to eventually give rise to primates. And from primates came humanity. Had the asteroids not struck, the world today would be unrecognizable. Dinosaurs might still dominate the land, mammals remaining small and insignificant. Primates may never have evolved. Humans would not exist to tell the story. In this sense, every person alive today carries the legacy of those impacts. Our very existence a consequence of destruction 66 million years ago. The impacts also left scars on the Earth itself, scars that endure to this day. Chicxulub lies buried beneath Mexico's Yucatan Peninsula, its outline mapped by geologists, its rocks drilled and studied. Boltish rests beneath Ukraine's soils, less famous but no less real. These craters are monuments to catastrophe, reminders that life on Earth is vulnerable to forces beyond its control. They also serve as warnings. The cosmos has not grown empty. Countless asteroids still wander the solar system, any one of which could be drawn toward Earth. The odds of another strike as large as Chicxulub in our lifetimes are low, but not zero. The dinosaurs did not have the means to see it coming. We do. The legacy of extinction compels us to prepare, to watch the skies, to ensure we do not share the same fate. Yet there is also hope in the legacy. Extinction was not the end of life, it was a transition. Earth recovered, slowly but surely. Ecosystems healed, diversity returned, and new rulers emerged. The resilience of life, its ability to adapt and endure, is as much a part of the legacy as the destruction itself. The double impact shaped the path of evolution, but it also shaped our perspective. It reminds us of how fragile dominance can be, how even the mightiest can fall in a moment. It humbles us, showing that humanity's place is not guaranteed, that we too are vulnerable to the forces of the cosmos. And yet, it also connects us. The rocks that fell on dinosaurs paved the way for us to rise. In their extinction lies our origin story. Every step we take, every word we speak, every civilization we build is possible because of that catastrophe. The legacy of extinction, then, is twofold. It is tragedy and opportunity, loss and creation. It is the story of how Earth can be broken and still recover, how life can be crushed and still endure, how from death can come new beginnings. 66 million years ago, 2 asteroids fell from the sky and ended the age of giants. Today, we walk the Earth they left behind. Their legacy lives in every forest, every ocean, every bird in the sky, and in us. The dinosaurs are gone, but through the survival and transformation they made possible, their story continues, written in the very fabric of life that followed.